Okay, so today we're going to be looking at number properties. So the learning goals, by the end of that lesson you should be able to identify basic number properties and use them to evaluate expressions. So the first thing we're going to look at is squares and square roots. So the square of a number is the number multiplied by itself. So for instance, a times a can be written as a squared, or 6 times 6 can be written as 6 squared, and the answer is that's actually 36. The square root of a number is a value that when multiplied by itself gives that number. So for instance, the square root of 9 is 3 because 3 times 3 is 9. The square root of 16 is 4 because 4 times 4 is 16. The square root of 81 is 9 because 9 times 9 equals 81. Okay, cubes and cube roots. So the cube of a number is the number multiplied by itself 3 times. So for instance, a times a times a, we write that as a cubed. Or 3 times 3 times 3, we're going to write that as 3 cubed, which equals 27. And the cube root of a number is the next thing we're going to look at. So the cube root of a number is a value that when multiplied by itself 3 times gives that number. So for instance, the cube root of 64 is 4, because 4 times 4 times 4 equals 64. So 4 times 4 is 16, 16 times 4 is 64. The cube root of 125 is 5, because 5 times 5 times 5 equals 125. 5 times 5 is 25, 25 times 5 is 125, and so on. So the cube root of 216 is 6, the cube root of 343 is 7. So hopefully you can see the pattern there. The next thing we're going to look at is the lowest common multiple. So the lowest common multiple of two numbers is the smallest multiple that's shared by both of those numbers. So I've got an example here to do. So find the lowest common multiple of 3 and 5. So the first thing you're going to do is list all the multiples of each of those numbers. So we'll start with 3. So all the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, etc. You could go on forever. And then we're going to list all the multiples of 5. So the multiples of 5 are 5, 10, 15, 20, 25, etc. Again, you could go on forever. And the lowest common multiple is the smallest multiple that both of those numbers share. So if you look here, the smallest number that they both share, the smallest multiple is 15. So 15 is a multiple of 3 and 15 is a multiple of 5. So the lowest common multiple of 3 and 5 is 15. Okay, highest common factor. So the highest common factor of two numbers is the largest factor that's shared by both of those numbers. So we're going to do an example as well. So find the highest common factor of 24 and 30. The first thing I would do is write all the factors of 24, all the factors of 30, and then we're going to try and find the highest common one. So we'll start off with 24. So the factors of 24 are 1 and 24. We've also got 2 and 12, 3 and 8, 4 and 6, 5 isn't a factor, and I think we've got all of them there. Then we're going to do the same for 30. So all the factors of 30. So we've got 1 and we've got 30. Next we've got 2 and 15, 3 and 10, 4, 30 can't be divided by 4. We've got 5 and 6, 7 isn't a factor, 8 isn't a factor, 9 isn't a factor. Okay, so we've got all our factors there, I think. So then we can find our highest common factor. So what number do they both share? So if we look here, they both share 6. So we can say their highest common factor of 24 and 30 is 6. The next thing we're going to look at is prime numbers and composite numbers. So prime numbers have only two factors, 1 and the number itself. So for instance, 3 is a prime number because the only factors it has are 3 and 1. 5 is a prime number, the only factors it has are 5 and 1. 7 is a prime number, again the only factors are 7 and 1. Whereas composite numbers have more than two factors. So for instance, 6 is a composite number because the factors of 6 are 6 and 1 and also 2 and 3. So you can see it's got more than two factors. Another composite number might be 12 because the factors of 12 are 1 and 12 2 and 6, 3 and 4. So you can see there's a lot more than just 2 factors. Okay, got some examples here. So the first one for A is a value, sorry, we've got a few examples here that we're going to evaluate. A is 11 squared. So we know 11 squared means 11 times 11, which equals 121. For B, we've got 5 cubed, and 5 cubed means 5 times 5 times 5. 5 times 5 times 5 is 125, because 5 times 5 is 25, 25 times 5 is 125. C, we've got the square root of 144. So the square root of 144, we have to find out what number times itself will equal 144. And the answer to that is 12, because 12 times 12 equals 144. And for D, we've got to find the cube root of negative, get rid of all of that, sorry. So the cube root of negative 8. So remember, a cube root is something multiplied by itself again. So for this, our answer will be negative 2. And we know that because negative 2 times negative 2 times negative 2 equals negative 8. Because negative 2 times negative 2 will give us an answer of positive 4, and positive 4 times negative 2 will give us negative 8. So hopefully you can see where we got that answer. Negative times a negative is a positive, and then a positive times a negative will give us a negative answer. So that's how we could do the cube root of that one there. That's the last example I've got for you with number properties. So make sure you watch over this video if you need to again. Make sure you take your notes and have a go at the textbook questions so you can practice these skills.